We can also perform face detection on videos. So the code is, first we need to import certain libraries. The first one is CV2. CV2 is open source library which contains the face detection classifier, and second is NumPy library which performs all the numerical computation. So CV2, it is a computer vision library. In simple language, the library which is used for image processing. All the operations which are related to images and are easy with this library, and this library is free for use. But now we are performing the face detection on videos. Video is again a sequence of frames. So it's easy to perform face detection on video as well, because video is nothing but it is a collection of frames, collection of images. So first we will import two libraries, which is import CV2, open CV library, and we will import the NumPy library. The second is we will load the classifier. Our classifier is hair cascade frontal face default.xml. So this classifier I'm going to use. This is the path where this classifier is present. When you install OpenCV, then in Anaconda 3 package, in Anaconda 3 folder, in library, site packages, CV2 and data, this hair cascade classifiers are there. You can choose any classifier whichever you want. You can also choose classifier for lip detection, smile detection, and there are n number of classifiers. So now we are just performing the face detection on video. So this is the face detection classifier. Now to load that classifier, there is method which is cv2.cascade classifier, and this cascade classifier method will load the classifier. The next is the input. Now my input is video. I'm not performing face detection on image. Now we are performing face detection on video. So for that, I will create one object using cv2.videoCapture. So this object is created by passing the name of the video. As my video is in current directory, so I don't need to pass the entire path. I'm just passing name of the video. And to capture a video, you need to create a video capture object. It captures frame by frame, and at the end, we release the video object. Here, the video is captured frame by frame, and at the end, we will just release this object, whichever we are creating now. So next step is, this is the object which we have created. This object will we will read the video frame by frame. Now, if this object is initialized properly, then this function returns true. Okay. So if this function is initialized properly, if the video is video path is correct, then we can check that with the help of this function which is capture.isOpen. If this function returns true, then it will jump here and it will start reading the video. But if this object is not initialized properly, then it will throw an error. Okay. So if you want to check if your video is initialized properly, if this object is initialized properly or not, you can check with the help of capture.isOpen. And if it returns true, it means that the object is initialized properly, or else it will throw an exception, an error. Once your object is initialized properly, it will read your video frame by frame. So capture.read method is used to read the video, and if it returns true, if there is some video, if there is some data, then let's convert this frame, all these frames, into a grayscale. Now we are going to convert our data to a grayscale. So gray is equal to cv2.color. cv2.color is a method which is used to convert the data to different formats. For example, here I am converting my video to grayscale. So cv2.color underscore bgr to gray. And here I am passing my data, that is my video. Okay. So it will convert the data to grayscale. And then after converting the data to grayscale, why we convert our data to grayscale? Because it reduces the noise from the data and it gives us the best face detection. Then we will perform the face detection on the video. For that, there is method which is detect multiscale face underscore cascade dot detect multiscale. And here we will pass three parameters. First, we will pass the gray object. Then this is the video. Then 1.3, this is the scaling factor. And 5 is the number of neighbors. Okay. Then neighbors means if I am specifying 5, then my algo will stop comparing after finding 5 equal images. And if you set it as 6, so it requires 6 images that must match with our provided image to detect a face. So these are the parameters which we can set for detect multiscale. After detecting a face, we will draw a rectangle around the face. So for that, we will initialize a for loop in which we will pass 4 parameters: x, y, w, h. X for location on x-axis, location on y-axis, width of the rectangle, and height of the rectangle. And this is a cv2.rectangle method is used to draw a rectangle in which we will pass our video frame we will pass. Then we will pass the coordinates where we have obtained the face, where we have detected face. And this is the color, like for example, if I want to draw a green rectangle, then in the same way I'll use the color code here and the thickness of the rectangle. Then to show the video or image in a window, there is a method which is cv2.imshow. This is the title of the window and this is my actual video. Then to stop that video, we need some logic. So this wait key waits for the user input. If the user presses escape button, then the video is stopped, the loop is breaks, and then finally the object is released. The object is released when the face detection is done, and cv2.destroy windows closes all the frames. So this is the code for face detection on videos. Now let's try and run this. So this is the video. This video works for frontal shots. So that's why this girl face is not detected here. For frontal shot, these algorithms work really well. See, this is again a frontal shot. This girl face is not visible properly. That's why the rectangle is not drawn. Okay. Now you can also change the speed of video by changing the value here. cv2.wait key. Here we pass the time. If it's too less, video will be very fast, and if it is high, video will be slow. Now let's change the value here and see the difference. See, the speed is now slow. Okay. So in this way, you can perform face detection on videos. You just need to pass the path of the video here or directly the video file name, and this is the path of the cascade classifier, and these are the steps. First, import libraries, then load the classifier, then create and instantiate the capture object, then check if the object is initialized properly or not. If it is initialized properly, then read the video frame by frame, convert that video to grayscale, perform face detection, draw the rectangle around the face, and with the help of cv2.imshow, create a window, and for termination, there is a key which is escape. So in the wait key, it wait for the user input. This is the time which is specified here. If the time is more, then the speed of the video is slow, and if the time is less, then the speed of video is fast. And finally, you have to release this object, video capture object, and you have to destroy all the windows, all the frames. Okay, so this is the code for face detection for videos.